In this presentation, we will see non-climate hazards, which are defined as the hazards that are out of the relation to climate change. For us to consider an effective adaptation programs, it is especially important to have a clear recognition of the difference between climate-related hazards and non-climate related. Similar to the hazards in general, there are two types in the non-climate hazards. One is those induced by human activities, and the others are natural hazards not affected by human beings. In the first place, we will see the human-induced hazard in relation to coastal structures as an example. As you know, socioeconomic activities in coastal areas are growing in the Pacific Island countries. They increase the coastal population, boost the country's economies, and facilitate the land use. Obviously, these are not climate-related factors. However, such anthropogenic changes affect the coastal infrastructures and therefore identified as human-induced or non-climate hazards in the discussion of adaptation measures. Population growth, economic development, and intensification of land use will facilitate the development and settlement in coastal areas. And such increases of human activities are likely to pose impacts and issues on coastal areas. For example, subsidence in coastal areas occurs due to excessive groundwater intake. Shoreline conditions are changed by the dredging around the coastal areas. Characteristics of sediment load and littoral drift are changed by infrastructure development, including development and port construction. Coastal environments such as water quality and natural habitats like corals and mangroves are affected by land use changes. Those impacts are anthropogenic drivers contributing to climate change and therefore different from those of natural origin. In other words, such human-induced hazards could be controllable. For our approach to more appropriate adaptation measures, it is important to have a clear understanding of such a difference. Next, I would like to discuss is a very common word but often used incorrectly. It is king tide. King tides, or the highest high tides of the year, are a unique coastal hazard. King tides are astronomical, and therefore the timing of these extreme water level events can be anticipated using tidal predictions, even though their impacts such as coastal flooding and inundation in low-lying areas can have devastating consequences for coastal inhabitants. King tides occur during a perigean spring tide at the time of new and full moon. In other words, a new and full moon must occur when the moon is closest to Earth in its elliptical orbit. So a king tide can be rewarded as an extreme spring tide, which is a more academic wording. Impacts of king tide are particularly serious when combined with severe weathers or high wave events. It is a common misunderstanding that king tides are the result of human-induced climate change. They are not byproducts of climate change. Rather, they're windows for us to see what the future of sea level rise from global climate change might look like along our coastlines. Occurrence of earthquakes is related closely to plate tectonics, a geological theory describing the large-scale motion of Earth's outer shell, which is divided into large slabs of solid rock called tectonic plates. An earthquake is caused by a sudden slip on a fault between the tectonic plates. In the left panel, you can see the different tectonic plates covering the Earth, and that seismicity is active along the borders between those plates. If you move your eyes to the right panel, you will see the seismic belt in the Pacific, which is part of the circum-Pacific seismic belt called Pacific Ring of Fire. Most of the earthquakes in the South Pacific occurs along this seismic belt, due mainly to the interaction of Pacific Plate and Australia Plate. Actually, the recent 7.7 magnitude quakes that struck Loyalty Islands on 11th February this year was located on the seismic belt in the vicinity of New Caledonia. You can see its epicenter, which is marked by red X. A tsunami is typically caused by large earthquakes that occur underwater at tectonic plate boundaries. Therefore, it is very common for tsunamis to occur in the Pacific Ring of Fire, where about 80% of tsunamis occur due to the tectonic activities. Please look at the left panel. U.S. National Climatic Data Center defined 10 tsunamigenic regions, including the 2 regions covering the West and South Pacific. Surrounded by those tsunamigenic regions, Pacific Island countries are inevitably vulnerable to the effects of tsunamis, which are generated locally, regionally, and even distantly. Unlike the ocean waves, which are generated by winds and move at a speed of up to 50 to 60 km per hour, tsunamis can move as fast as jet plane, 800 km an hour or even faster over deep oceans, and can cross entire oceans in less than a day. Please turn your eye to the panel on the right. It exhibits records of tide stations which detected tsunamis generated by Loyalty Island earthquake. If you take a closer look at the seismic data, you will see that tsunamis reached at all the tide stations within 3 hours' time. For example, Great Barrier, New Zealand, located about 1,500 km from the epicenter, detected the first tsunami at around 16, about 2 hours and 40 minutes from the earthquake's occurrence. It means that tsunami reached the station at a speed of 560 km an hour on average. A volcanic eruption is a geologic hazard in which molten rock, gases, ash, and other materials are released onto. As with earthquakes, volcanic eruptions break out as a result of interactions of adjacent tectonic plates. Many volcanoes in the Ring of Fire were created through a process of subduction, and most of the planet's subduction zones happen to be located in the Pacific Ring of Fire. 2 panels on the right show the volcanic ash cloud approaching Fiji, which was released from Manaro volcano of Vanuatu at its eruption in 2018. The eruption forced many islanders to be displaced with heavy ashfalls and landslides. Volcanic ash also caused serious trouble to aviation. A large-scale eruption could disrupt international air traffic across a very broad range over an extended time period.